Welcome students. Today we will see this exercise 2.1 in that question number 1. The graphs of the y is equal to p of x are given in figure 2.10 below. Here these are the 6 graphs he has given for some polynomial p of x. Here what we have to do, find the number of zeros of p of x in each cases. For example, we will take this first case. Here we have to find out the number of zeros. For that he has given a graph, that is, see here one line, it is parallel to the x-axis, means here this graph is not touching to the x-axis nowhere. So number of zeros, how many number of zeros we have to find out. Here number of zeros can be found out by how many times the curve touches to the x-axis. Suppose if it touches one time, then the polynomial has got 1 zero. If it touches to 2, it has got 2 zeros. Like that we have to find out. Now here this is parallel to x-axis, so no zero. Number of zeros are 0, means there are no zeros. No zeros exist. No zeros exist. For second case, we will see this graph is touching to the x-axis at this point, means only one time it is touching to the x-axis. So number of zeros is equal to 1. So automatically number of zeros is equal to 1 is nothing but it is a linear polynomial that we can decide. This is linear polynomial, because in linear polynomial the degree of x is equal to 1 and the number of zeros is equal to 1 and the curve is also touching to the x-axis at only one time. Hence the number of zeros is equal to 1. Here how many times the curve touches to the x-axis, from that basis we can find out how many zeros are exists. So for this example, for the third case, see here the graph, it is touching at this point and at this point and at this point. 3 times it touches to the x-axis. So number of zeros is equal to 3. So here it is a cubical polynomial like this. So here find the number of zeros in each case, means number of zeros only we have to tell. We should not be able to tell this cubical polynomial or linear polynomial, that it doesn't matter. So now here in the fourth case also it is touching to the 2 times it is touching, whether it may be in the negative direction or it may be in the positive direction. See here number of zeros is equal to 2. Okay. Now in this case, here in this case, in the fifth case, the curve this will touch to the x-axis at 1, 2, 3 and 4. So here number of zeros is equal to 4. And in the same way, this is 1, 2, 3, only 3 times, that is number of zeros is equal to 3. So here we have to understand that this curve is touching to the x-axis at only one point, not at 2 points, because see the tip of the curve is touching to the x-axis at 1 point only. So there are 3 points. So number of zeros is equal to 3. That's all. So we will go for the next exercise. So in this exercise 2.2, in that question number 1, here in this question, find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficients. So the zeros of this polynomial and the coefficient of this polynomial. So here these are the quadratic equations, because see the degree of these equations are 2. So first we will take first case, that is x square minus 2x minus 8. Okay. Here the variable is x and the degree is 2, because highest number of degree in the polynomial is 2 only. This is 2, this is 1. So 2 we will consider. So this is a quadratic polynomial. So now in this quadratic polynomial, so before going to find out this relationship, as we know that already for linear polynomial, for general equation, that is ax plus b, the zero of a polynomial is equal to zero of this type of polynomial is equal to minus b by a, that is minus of constant term divided by the coefficient of x. So this we have already seen. So in the same way, for quadratic equation like this ax square plus bx plus c, for this type of equation, we know that in the theory we have already understood that the sum of zeros is equal to minus b by a, and the product of zeros is equal to c by a, where b is the see here, minus coefficient of x divided by the coefficient of x square, and the product of zeros is equal to constant term divided by the coefficient of x square. Denominator will be coefficient of x square only. For sum of zeros, it will be coefficient of x divided by coefficient of x square, and product of zeros is equal to constant term divided by coefficient of x square. So now we will go for this one, first one, that is x square minus 2x minus 8. Okay, so first we will find out zeros of this polynomial, So how to find out this? This one can be find out by considering this constant term and the coefficient of this x square. So for example, the coefficient of x square is 1 and the constant term is 8. So whether it may be a minus or plus. So 1 into 8, which is equal to 8. So we will see the factors of this 8 first. So 2 4s are 8, 2, 2. So 2, 1. So 2, 2 and 2. So by making these factors, we have to find out the middle term. So like this, 2 into 2, 4. This is 1 and this is 2. So 4 minus 2 is equal to 2. By adding or subtracting these factors, by adding or subtracting the factors, we should get the middle term. Like this. See, x square minus 4x plus 2x. So minus 8 will be written as it is. So here you can see the resulting. Minus 4x plus 2x is equal to minus 2x only. So this middle term has been splitted in this way. So here, now we will take the common in this 2 and common in this 2. X square minus 4x will be x into x minus 4. So in the same way, here 2x minus 8, 2 will take, x minus 4 will be inside. So here in this, x plus 2 and x minus 4, these two equations, these will become zeros when you equate it to the zeros. So x plus 2 is equal to 0, so x is equal to minus 2, and x minus 4 is equal to 0, so x is equal to 4. So this minus 2 and 4 are the zeros of this polynomial, So by factorizing this polynomial, we can get the zeros of the polynomials. So this the second part will be, we have to verify between these zeros and this coefficient of this polynomial. So now we will see, we have seen this one, sum of zeros equal to this one, product of zeros equal to this one. So in this equation, that is x square minus 2x minus 8, in this a is equal to 1, b is equal to minus 2, c is equal to minus 8. So sum of zeros can be find out by using the formula minus b by a, which is equal to minus into minus 2 divided by 1, so it is equal to 2. And in the same way, product of zeros is equal to c by a, which is equal to, c is nothing but minus 8, a is equal to 1, so it is equal to minus 8. So sum will be 2 and product will be minus 8. So now we will verify. This we have got. These are the zeros, minus 2 and 4 are the zeros. So we will verify as per this one. See, the sum of zeros we have got 2. We will add this one. For example, this is alpha and this is beta. This is one of the zero, this is another 0. So alpha plus beta is equal to minus 2 plus 4, which is equal to 2 only. So this 2 and this 2 is verified. In the same way, alpha into beta is equal to minus 2 into 4, which is equal to minus 8. So this minus 8 and this minus 8 will be verified. So whatever we have done, it is correct. So we will go for this second one. So here 4s square minus 4s plus 1. Same way, factorization we will do, that is 4 into 1. So 2 2s are 4, that's all. 2 1s are. So here 2 2. So by adding these 2, we will get the middle term. So 4s square minus 2s, so minus 2s plus 1. Okay. So here in this we will take common as 2s, we will take common. So here s, 2s minus 1. So here minus 1 will take, so that 2s minus 1. So that this term and this term should be equal. So we can take a common. 2s minus 1 and another 2s minus 1. See, this 2s minus 1, this 2s minus 1, it is equal to this one, and this 2s minus 1 is equal to this 2s minus 1. So this we will equate to 0. So 2s minus 1 equal to 0. So s is equal to 1 by 2. And one more term, it is also same, s is equal to 1 by 2. So this is one, alpha is equal to this one, beta is equal to this one. So we will verify by using this coefficient method, that is A is equal to 4. Here A is equal to 4, B is equal to minus 4, C equal to 1. A equal to 4, B is equal to minus 4, C is equal to 1. Sum of zeros is equal to minus B by A, which is equal to minus of minus 4 divided by 4, which is equal to 1. Product of zeros is equal to C by A, which is equal to C is equal to 1, A is equal to 4. So this is equal to 1 by 4. So this is alpha and this. So this is alpha plus beta. This is alpha beta. Okay, we will see this alpha and beta. So here alpha plus beta is equal to how much it is? 1 by 2 plus 1 by 2. It is equal to 1. So this one and this one, it is verified. So alpha beta is equal to 1 by 2 into 1 by 2, which is equal to 1 by 4. So this 1 by 4, this 1 by 4, verified. So in the same way, we will go for third one. Here 6x square minus 3 minus 7x. We will rearrange 6x square minus 7x minus 3. Constant term will be 3 and coefficient of x square equal to 6. 6 into 3, it is equal to 18. 18 factorization we will take. So 2 9s are 3 3s are 3 1s are. So 2, 3 and 3. So by making some combinations, middle term. So here 3 3s are 9, 9 minus 2, 7. Say 2 and 3 3s are 9. So 9 minus 2 equal to 7. So 6x square minus 9x plus 2x minus 3. So here in this 2 we will take common and in this 2 we will take common. So here 3x will take. So 2x, okay, minus 3 plus 1 into 2x minus 3. So 3x plus 1, one term, 2x minus 3, one more term. 3x plus 1 is equal to 0. So x is equal to minus 1 by 3. In this term, 2x is equal to 3, x is equal to 3 by 2. So this is alpha, this is beta. So alpha is equal to minus 1 by 3, beta is equal to 3 by 2. This we have got zeros. So now we will verify with the coefficients. So for verifying that, we will take sum of zeros is equal to minus b by a. In this minus b means this one. This is b. So minus of minus 7. A means 6. This is 7 by 6. Sum of zeros. Product of zeros. C by a. C means minus 3. A means 6. So minus 1 by 2. So we will verify this one. Alpha plus beta we have got this one. Alpha plus beta we have got 7 by 6. Alpha into beta we have got minus 1 by 2. So we will verify with these zeros. Alpha plus beta is equal to minus 1 by 3 plus 3 by 2. LCM 6 minus 2 plus 9 is equal to 7 by 6. This 7 by 6, this 7 by 6 verified. Alpha into beta is equal to minus 1 by 3 into 3 by 2 is equal to 3 3 cancel. This is minus 1 by 2. This one and this one verified. Okay. Next we will go for fourth one. That is 4u square plus 8u. Here in this, the third term constant is 0. So for that we will take common 4u, we will take common u plus 2. So this to be equated to the 0 so that we can find the zeros. So now 4u is equal to 0 one portion, u plus 2 equal to 0 another portion. So u is equal to 0 and u is equal to minus 2. So these are the two zeros, 0 and minus 2. Okay, now we will verify with the coefficients of these equations. So here 4u square plus 8u, we will write it plus 0. So this is in the form of ax square plus bx plus c. So here a is equal to 4, b is equal to 8 and c is equal to 0. So sum of zeros is equal to minus b divided by a, which is equal to minus 8 by 4 equal to minus 2. Then product of zeros is equal to c divided by a. C is equal to 0, a by a is equal to 4. So this is equal to a, 0. So now we will see this is alpha and this is beta. Okay, so alpha plus beta is equal to minus 2, this is, and alpha into beta is equal to 0. Okay, so now we will verify this one. Alpha plus beta is equal to 0 plus minus 2 is equal to minus 2. Alpha beta is equal to 0 into minus 2 equal to 0. So this alpha plus beta equal to minus 2, this is verified with this one, and alpha beta is equal to 0, verified with this one. So we will go for next question. So in this fifth question, t square minus 15. So here we can write this 15, because see, this 15 is not any square. So hence we will write this t square into root 15 square. This is one and the same. So now this is in the form of a square minus b square. The formula, as we know, that a minus b into a plus b. In this form we can able to write. So hence in the same way, here a is equal to t and b is equal to root 15. So a plus b means t plus root 15 and a minus b means t minus root 15. So this both will equal to 0. So t is equal to minus root 15 and t is equal to plus root 15. So these are zeros, that is alpha beta. Okay, now we will find out as per this coefficient of the equation, that is ax square here this is t square minus 15. In this, a is equal to 1, that is coefficient of x square or t square 1. B is equal to 0 because b term is missing here. So c is equal to minus 15. So now sum of zeros is equal to minus b divided by a. So minus 0 divided by 1 equal to 0. Product of zeros is equal to, this is alpha plus beta, this is alpha beta. Okay, so c by a, c is minus 50, a means 1, so this is equal to minus 50. So now here we know alpha and beta, so we will verify with this one. Alpha plus beta is equal to root 15 minus root 15 plus root 15. This is equal to 0. This is 0, verified. Alpha into beta minus root 15 into plus root 15. So this is equal to root 15 root cancels. So this is equal to minus 1. This is verified. So we will go for next session. Here in this sixth question, that is 3x square minus x minus 4. Here 4 into 3, which is equal to 12. The factors for this one will be 2, 6, 2, 3 and 3 ones. So here only one should get 4, 3. So 4 into 3 equal to 12. 4 minus 1, 4 minus 3 is equal to 1. So 3x square, okay, plus 3x minus 4x minus 4. Because see, 3x minus 4x will be minus x. So 3x will take common, x plus 1 minus 4 will take x plus 1. So 3x minus 4, then x plus 1. Both will equal to 0. 3x minus 4 is equal to 0. X is equal to 4 divided by 3. And in this, x plus 1 is equal to 0. X is equal to minus 1. So alpha is equal to 4 by 3. Beta is equal to minus 1. So here sum of zeros is equal to minus b by a. So here b means minus 1, minus of minus 1, a means 3, so this is equal to 1 by 3. So product of zeros is equal to c divided by a. C is constant term, minus 4 divided by 3, this is equal to minus 4 by 3. So now alpha plus beta, this plus this, alpha plus beta is equal to 4 by 3 minus 1, because plus 1 plus of minus 1, we will take LCM. So 3, 4 minus 3 equal to 1 by 3. So this will be verified. Alpha into beta, 4 divided by 3 into minus 1 is equal to minus 4 by 3. So this is also verified. So this completes exercise 2.2. So now exercise 2.2 in that question number 2. Here find the quadratic polynomial each with the given numbers as the sum and product of its zeros are respectively like this. So this is sum of the zeros and this is the product of the zeros. So we will take this first one. So sum of zeros is equal to, that is nothing but alpha plus beta he has given. So which is equal to 1 by 4, and product of zeros, that is alpha into beta is equal to minus 1 he has given. This is given data. So we have to find out the quadratic polynomial. That is quadratic polynomial, it is a general expression will be ax square plus bx plus c. This is a general expression of the quadratic polynomial. So here how to find out this one? By using this sum of zeros and product of zeros means, that is polynomial can be written x square minus alpha plus beta into x plus alpha into beta. This is given, this already we know. So hence we will substitute these values and find out the polynomial, that's all. So x square minus alpha plus beta he has given, that is 1 by 4 into x plus alpha into beta minus 1 he has given, so minus 1. So x square minus x divided by 4 minus 1. Okay, this is the polynomial. This can be further simplified by taking LCM, that is 4. So 4x square minus x minus 4, which is equal to 0. So which is 4x square minus x minus 4 is equal to 0. This is the polynomial. So now second portion, that is alpha plus beta he has given root 2, alpha into beta is equal to 1 by 3. So quadratic equation can be written as x square minus sum of zeros into x plus this product of zeros. So here x square minus sum of 0 is equal to root 2 into x plus 1 by 3. So we can multiply this whole equation with 3, so that 3 into x square minus root 2x plus 1 by 3 and is equal to 0. This is also multiplied with 3. So this will become 0 only. So here 3x square minus 3 root 2x plus 1. This 1 by 3 into 3 means 1. So this is equal to 0. This is the quadratic polynomial. So third one, 0 and root 5. So x square minus 0 into x plus root 5. So here x square minus root 5. This is the polynomial, that's all. And this fourth one, x square minus 1 into x plus 1. So this is x square minus x plus 1. Then fifth one, x square minus of 1 by 4 into x plus 1 by 4. X square plus 1 by 4 x plus 1 by 4. Here you can multiply both sides by 4. This is 4 and this is 4. Okay, 4x square plus x plus 1 equal to 0. So this is the polynomial. And this was sixth one, x square minus 4x plus 1. That's all. Okay, now we will go for next exercise.